And this is one of the first afternoon lectures, and this is a lecture by Professor Durlauf. And I'm extremely honored to chair this session. My name is Matthew Shi, and I'm with the CUHK. And before we want to hear the lecture, wonderful lectures, and let me just introduce Professor Durlauf briefly. And Professor Stephen Neil Durlauf is the William and Willis Research Professor and the Kenneth J. Arrow Professor of Economics at the University of Wisconsin-Madison. He is a fellow of the Econometric Society and the Research Associate of the National Bureau of Economic Research. In the year of 2011, he was elected to the American Academy of Science and Sciences, Art and Sciences. And he is currently a co-director of the Human Capital and Economic Opportunity Working Group at the University of Chicago. Previously, Professor Durlauf served as the Economic Program Director of the Santa Fe Institute from the year 1996 to 1998. And I'm pretty sure that almost all of us have seen Professor Durlauf's name in our career because he was the general editor of the New Paragraph Dictionary of Economics, revised edition, published in the year of 2008, the most extensive compendium of the economic knowledge in the world. Professor Durlauf's research spans many topics in microeconomics, macroeconomics, as well as in econometrics. And yesterday, when I look at Professor Durlauf's CV, I think his publication is sufficient to support the tenure decision of about 15 assistant professors here. So much of his research has attempted to integrate sociological ideas into economic analysis. His major methodological contributions include economic theory and econometrics. He helped pioneer the application of statistical technique into the modeling of socioeconomic behavior and also developed identification analyses for empirical analog of these models. And the other research have focused on the technique for monetary policy and evaluation. Professor Durlauf is also known as a critic of the use of the concept of the social capital by economists and other social scientists, and has also challenged the way that the agent-based modeling and complexity theory has been employed by social and natural scientists to study socioeconomic phenomena. So let's welcome Professor Durlauf to give his lecture. Thank you.
Very nice, thank you. Very grateful for that introduction. I'm also deeply embarrassed, but thank you. And thank you to the organizers for inviting me. It's an honor, obviously, to have the opportunity to speak at these meetings. So what I'm going to talk about today is a paper and the first important thing to say is with my colleague at Wisconsin, Ananth Seshadri, called Understanding the Great Gatsby Curve. So with 35 minutes and 150 slides, I'm going to be skipping most of them. And if you think I have too many slides, you haven't seen anything yet. Okay. And so, to sort of understand what this paper is trying to do, substantial publicity was given to work by Miles Korak, both within social science and within economics, when he made the observation that when one looks across the OECD, there seems to be a positive association between measures of inequality, cross-sectional ones such as the Gini coefficient, and measures of the persistence of socioeconomic status across generations. The term the Great Gatsby Curve, the reference to the American novel, gave it substantial cachet in public policy debates, but I do want to emphasize that this was an observation by Miles Korak, who is the originator of the idea. What we try to do in this paper is to move from the cross-section idea, in other words, the concept that one looks at different aggregate economies and makes observations about the correlatedness of mobility and income inequality, towards a different conception, or a complementary conception of the Gatsby curve, in which the thought experiment is to focus on an intertemporal Gatsby curve, which is a question of whether, as one studies a particular economy in time, does one seek changes in cross-sectional inequality associated with changes in mobility? And so the thought experiment here is a bit different. In other words, if one's going to compare Scandinavia to the United States and the UK, if one's going to take the endpoints of the cross-sectional Gatsby curve, one has led to certain questions about political economy, culture, institutions, and the like that are somewhat different than asking a question within a given economy, one would make this observation. And so what we're going to argue in the paper, and we're going to do this at 3 levels, is really pretty simple, and that is that if one thinks about cross-sectional inequality, what that is going to do is going to alter the environments in which individuals develop. And the alteration in those environments transmits the cross-sectional inequality into the rate of mobility or its lack thereof. So in understanding that, the way that we're going to think about it is going to be somewhat sociological, but it's also going to, certainly it'll be social in the sense it's going to be focusing on the relationship between cross-sectional inequality and segregation within a society. And so what we mean by that is the following, and that is, and obviously this is an American-centric paper, so we're going to have some institutional details that are specific to the United States, and that is that if one considers the consequences of increases in the dispersion of income within a generation in the United States, that there's 2 phenomena that occur which have consequences for intergenerational mobility. Both of those consequences are going to derive from the idea that the greater the inequality cross-sectionally, the greater the socioeconomic segregation of communities. And so the thought experiment is, as inequality increases, there's more segregation of neighborhoods and communities by income, and that increased segregation will decrease the rate of intergenerational mobility. And so that'll be for 2 reasons. Reason number 1 is going to have to do with the political economy of education in the United States, and that is that substantial generation of revenue for education is done at the school district level. And so what that means is operationally something between 35 and 40% of revenues are generated by school district tax bases, and as a result, changes in the segregation of communities by income is going to alter the revenues that are being generated for the public good called education. The second mechanism that's built into the paper is the one that I'm going to call social, and it is one that is taken and really inspired by substantive ideas in the sociology literature, in which there's an argument that if one thinks about the distribution of socioeconomic characteristics in a community, that has a plethora of effects on children. It can be ranging from role models to social learning to peer effects and the like, but all of those collectively create a separate channel in which the distribution of outcomes amongst adults in a community have consequences for the development of children within it. Now, the way we're going to make this idea concrete is in the context of residential neighborhoods, and focusing on the notion of what is income segregation. But one of the things we want to emphasize is that the mobility, this argument actually is really quite general. In other words, in a plethora of different socioeconomic environments, one can make the same argument that when one increases segregation, when increases inequality, incentives for segregation increase, and so one has a mapping from increased segregation, dispersion of some characteristics to increased segregation to intertemporal consequences. One example of that would be the interaction of complementarity in production functions with increased dispersion of skills. That enhances the incentives for sort of matching, and one gets exactly the same phenomena. And a student of mine, Kyu-Yan Kim, who will be on the job market this year, is exploring that in the context of the United States. All of these ideas really have to do with the following kind of big picture conception of inequality, which in work a number of years ago I called the so-called memberships theory of inequality. And the idea is to focus on the following, and that is that if one wants to understand the dynamics of inequality, one of the phenomena that matters is the memberships an individual has. Those memberships can range from the family. That's going to generate the standard models of transition of socioeconomic status. I seem to have lost power. From parent to offspring, to firms, to neighborhoods, to schools. And in which case, what matters is the relationship between the identity of an individual and the particular grouping that he or she finds himself or herself in. All right, so what we do in this admittedly long paper is the following. We first construct a theoretical model which links neighborhood segregation and mobility, which will directly create this inequality mobility nexus that I've described. In other words, what we do is we trace out the dynamics of an overlapping generations model, which embeds the mechanisms for which I've given the intuition. And then the second half of the paper is to provide 3 pieces of evidence in support of the perspective we're taking. Now, to be clear, this is not a theory of everything. There's not going to be any claim in the paper ex ante that this explains changes in intergenerational mobility in their totality, or for that matter, the levels of it in isolation. Rather, what we want to do is argue that at 3 different dimensions, there's empirical reasons to believe that this argument's good. And we'll make those in the following sense. I'm going to give you some stylized facts that are supportive of that. Second, I will provide you some reduced form intergenerational mobility regressions, which augment the traditional ways people estimate mobility, do statistical analyses, and show that there's some group effects. And then finally, we'll give you a structural model, which is consistent with the story that we give. Okay. So what we conclude is, and I want to be very clear about this, is we do not have great evidence that our theory has substantial explanatory power with respect to mobility and intergenerational mobility dynamics. What we mean by that is that we can't, at the end of the day, say this is an exercise that says this is the theory, this is the explanation of data on Gatsby curves within an economy. Rather, what we make a claim is that we could explain something on the order of 20% of changes in mobility. And that's, in our judgment, worth knowing. All right, so what do I mean about this mobility inequality relationship? The algebra of that's really very simple, and that is if one thinks about the canonical intergenerational mobility regression, it's taking the log of income and regressing that of parents against that of offspring and interpreting the coefficient beta as the measure of persistence in a society. Now that model by itself does not generate a Gatsby curve, and what I mean by that is if one thinks about the relationship between beta and the variance of incomes, that's really just a first order vector autoregression. And the only sense in which there's a relationship is if you change causally, you could say if you change beta, that changes the variance of income. We're interested in a different approach, which is to say that there's cross-sectional inequality that determines the level of mobility, and that's obviously the temporal logic of the model. And so if one starts off with micro-foundations that are strictly linear, there's not going to be a Gatsby curve. And so really what I'm trying to say is that efforts to link cross-sectional inequality through some set of mechanisms to changes in mobility are going to represent some generalization of the standard intergenerational mobility regression, and intuitively what we're doing is no deeper than to say that that coefficient beta is not a primitive. It is a function of various variables. Take x as the placeholder, and different theories of which can generate the Gatsby curve can be understood as different choices of the variable x. And so the reason that I say different theories is this is not the only paper to propose a way of generating a Gatsby curve. Some papers have argued that the relationship between income and of parents and offspring is nonlinear. By itself, that will generate, potentially, if the relationship has the right type of nonlinearity, a Gatsby-like relationship. Okay, that's work of Casey Mulligan, for example. A different approach is to argue that the marginal payoffs to increased investment in children are increasing in the human capital of parents. That would make the variables X human capital of parents variables, and that's the work of Becker, Murphy, Commoners, and Spencook. In this paper, we take a different set of variables, and that is we argue that social variables are creating heterogeneity in those beta coefficients. That's what's generating differences in mobility across individual families. And so again, what I want to emphasize is a way to think about this as a mapping of some theories to these very basic statistical models is that the baseline statistical models are linear regressions. Each of the theories that is being, at least ours and other theories that purport to explain the Gatsby curve are really extensions of the statistical model. They're taking stances on the variables that are determining the intergenerational mobility coefficient. All right, so theory. Basically, what we present in the paper is an analog, or I should say a complementary approach to the Becker-Tomes model. So classic models of intergenerational mobility are driven by families. The thought experiment, be it Lowry or Becker and Tomes, and I'll focus on the latter because that's the paper we're most closely parallel with, have a certain logic. Parents make investments in their children directly. that educational investment in the child produces the capacity for earnings as an adult, and that creates a mapping from the parent's income to the offspring's income. What is key in that is that parents do not engage in borrowing or lending, and so it's the parental income that defines the budget constraint from which the investments come. So what we're going to do in this model, and what I call it a social analog, is, and as a thought experiment, we're going to virtually ignore the direct investments of parents. Rather, a way to think about it is Becker Holmes is a private education economy. So you could say that's the model of the 19th century aristocrats who get to hire tutors of various qualities for their parents. That's supposed to make everybody laugh, but so on. So whatever. Our model is treating education as a public good. In other words, there are collectivities that produce this public good called education, and hence it's the distribution of incomes within the relevant collectivities that is going to create the mapping. Why do and that's true both for the local public finance I mentioned and because of the social factors. What gives a role to parental income here is the ability to purchase memberships or to become a member of the relevant collectivities. And so one can think about neighborhoods, communities, and the like in this model. Granted, it's obviously a grossly oversimplified, everybody says that, grossly oversimplified model. In this case, income is a sufficient statistic to determine membership in a given community. But once the community is formed, education is done socially. All right. So, given the extreme lack of time, and really what I want to do is just tell you what's in the model, and I want to give you two results for the model, and I'm going to skip over many boring equations. And they're not boring because they're equations, but because they just aren't particularly insightful. All right, the first idea is very simple, and that is that following Becker-Holmes and the standard literature, what's essential in the model is the determination of human capital of children. There's going to be a process in which human capital is determined. There'll be a set of mechanisms, factors that determine it. That human capital, combined with something you can call labor market luck, in other words, some additional heterogeneity, will determine adult income. Okay, that's standard. Second thing in our model is that it is going to be determined socially. And again, and that I've already described to you. There will be local public finance of education. It's determined as a collective good. And the productivity of educational investments will be influenced by the characteristics of members of a community. Now, in the logic of the model, we're going to treat that as something of a black box. What I mean by that is we're going to specify functional forms or choices of variables in certain functions that say there's a relationship between the distribution of income and the productivity of an educational investment. The micro foundations of that are not explicit in the models, and I want to be clear about that. So what's going to happen in the model, in other words, is that the relevant choice of parents are the neighborhoods in which they live. And so that leads to two ideas. First of all, what is it that parents prefer in a neighborhood? And the logic of the model, again, really is assumed, or at least trivially derives from the preferences that we describe, is that parents like two things in a neighborhood. First, they prefer more affluent neighbors. Rightward shifts of the income distribution have benefits in terms of both the tax base and the associated social interaction effects. Second, parents, however, also put a value on larger communities. Now, in the model, the cheap way to do that, which is what we do, is to introduce some non-convexities in the production of education. In other words, there's fixed costs and the like. One can have an intrinsic desire for size of neighborhood and would give qualitative exactly the same results. But what's going to matter here are these two ideas. One of them is a preference for more exclusive communities versus a preference for larger communities. Once preferences are specified that way, then the question is what happens in equilibrium as parents are making the choices of communities. And so what will happen in the model is we will take a very weak stance on the neighborhood formation process and just require allocations of families and neighborhoods are core allocations, and you'll see what I mean by that. And what that's going to mean is that families form neighborhoods based on the ability to erect income barriers. Those turn out to be supportable by prices, so that's not an interesting distinction in what the mechanism is. And so the bottom line is these two preferences that I give you create incentives for segregated neighborhoods. But the degree of segregation is determined by the distribution of income. A trivial form of segregation is everybody lives in the same neighborhood. The most extreme form of segregation is every family lives in its own neighborhood. That's the Becker-Holmes model. What this model allows is every possible configuration of neighborhoods. All right. So once that's set up, then the mechanism I described comes into play. What one can show is, first of all, this model can generate extremely persistent income between generations. In fact, it has the potential for generating poverty traps as well as permanent inequality with respect to the upper tail. But whether those phenomena occur or not will be determined by the degree of segregation. The upshot of the model is the following, and that is, as cross-sectional inequality increases, if the cross-sectional inequality changes the distribution, the degree of segregation, exclusivity of communities, the degree of social isolation in certain ways, that will enhance the persistence of socioeconomic status across generations, and that will generate the Gatsby curve. Okay? So everything that I say in terms of the formal theory is simply an instantiation, working from preferences, constraints, and beliefs to equilibrium and the like of those four ideas. All right. So those are the ideas. What I want to now do is make one additional observation and then go to the two theorems that are interesting. Okay, the observation I want to make is that the model, when I go through the algebraic detail, is actually, it is by construction a model that has endogenous growth. And what I mean by that is that the model actually has highly linear technologies in there. And what I mean by that is no deeper than when parents invest in their children, the rates of return are not declining to zero as the investment becomes arbitrarily large. And so in the tradition of the sort of AK models of Rebello and others, or the endogenous growth models of a cast of thousands, in each case, what is generated in the model are income trajectories for each individual family dynasty that are growing across time. All right? And so the idea is going to be that we don't think about a stationary environment in which all families have the same average incomes over time, and the only question is the rate of transit of the Markov processes that are defining intergenerational dynamics, but rather this is an economy in which all incomes are growing, but they're growing at different rates. And those rates of growth are being determined by the neighborhoods. In other words, the various social factors that I've written. And so as a result, one thinks about the characterizations of inequality qualitatively differently here than one does in a stationary environment. And so what I mean by that is if you think about a stationary economic environment, intuitively what that means is you have a set of family dynasties, and in each generation, with some 1 minus epsilon probability, there's an upper and lower bound to the incomes. So if I think about processes of families moving across time where they each have upper and lower bounds and they're Markov processes, and there's non-trivial heterogeneity, shocks in each generation, things such as ability shocks, luck, what have you, eventually these Markov processes are going to crisscross. And that's what I meant when I said stationary economies, unless you shut off the mechanisms that are creating the unobserved heterogeneity in these models, they always generate long-run equality across the generations. It's only the very special cases that don't do that. You have to rig them a certain way to get permanent inequality. Something very different is happening here. What happens in this model is that if one thinks about the distribution of incomes, that 1 minus epsilon metaphor for each generation, the size of that distribution, its support, is increasing. So it's in a cone, in other words, a growing cone that one traces out the mobility dynamics by comparing different generations. And if you just get a picture in your head now of this cone where I'm drawing generations, the dynasty dynamics, because the cone is growing, there's many more places for those dynamics to go in which they never overlap or they never crisscross. And crisscross is just an informal way of saying relative socioeconomic status reverses itself. And so one of the messages of the paper, and there's cumbersome algebra to generate all that, but there's a specific intuition, is that in growing economies, there is much more space in the set of socioeconomic outcomes to permit forms of permanent inequality, which are simply unnatural in the strictly stationary environments. All right, so that's really what I want to say. And so what's it mean to write down a model? One specifies a demography. That's going to be a description of a set of family dynasties in which one traces out the dynamics with very simple assumptions, lack of marriage, in other words, asexual reproduction, 2 generations of life and the like. The second thing is to choose preferences. Here in the model, the key to choosing preferences, we chose Cobb-Douglas because that simplifies the political economy. One of the issues in any model like this, of course, is to make sure that preferences have the property that once a neighborhood is formed, there is a majority voting equilibrium for the tax rate that generates the revenues for the public good. And so there's different ways to do that. The cheapest one is, or the easiest ones, to choose Cobb-Douglas, which means that everybody has the same preference with respect to budget shares, of which one in this case is the taxes they pay. Third idea is that there's going to be a mapping from human capital to income to human capital to income. As I said, we want to have a growing economy. That means that we're going to have an equation like 4 in which there's some linear relationship. That means in logarithms, everything's nice and additive, and that gamma becomes phi becomes very important. Family expenditures in this case are social. They're divided between taxes and income. One has a very linear, we need a simple tax rule. It's going to be linear, and which means that every neighborhood, once it forms, sets a linear tax rate. Doing something substantially more sophisticated is beyond my capacity, at least, to understand what you would do, since you always run into the danger that everybody will vote 100% tax for the highest income family, ... And so the serious point, again, is to ensure existence of equilibrium neighborhood configurations. One has to be careful on defining the space of candidate taxes. Total expenditures are just generated by taxes. Then what we put in the model is a relationship between the total expenditures available for education and the quality of education. We built in a non-convexity. We add to that now a mapping from educational quality to human capital. That's equation 9. It's linear. That was the idea, that we want the model to have growth across time. And at the end of the day, the final question is how neighborhoods form. And so the way neighborhoods form is very simple here. What we do is we allow neighborhoods to be able to vote in zoning restrictions. That means that every neighborhood can set a minimum income requirement for membership. In the United States, the important institutional feature is the capacity of communities to limit the nature of the residences that exist. As an example, when I owned a house that was in a neighborhood that had a rule that no lot in that neighborhood could have a multifamily dwelling. What that means in English is no apartments were allowed in this particular community. And so if one wants to understand the degrees of income segregation in the United States, it's not just a matter of willingness to pay in isolation simply because of social interaction effects that's segregating rich and poor. It's the interplay with that with collective decisions that alter the opportunity set with respect to the quality and the nature of the housing that's available. All right, and so that's where we are. And the political economy is very simple, which is that the equilibrium neighborhoods are going to be in a core. What that means is any group of families, if they wanted to, could withdraw from the current neighborhood configuration and form another one. That gives arbitrary flexibility in the size of the neighborhoods. That doesn't impose any degrees of segregation or integration, which you would have if you had a fixed number of neighborhoods or population sizes. And the Cobb-Douglas assumption ensures that that the political economy within the neighborhoods is trivial. There's agreement on the equilibrium taxes. All right, so that's the entire structure of the model. What I want to say is the following, and I'm going to give you just a few properties of the model. The first is that if you look at the equilibrium configurations in this model, because preferences are not heterogeneous, every equilibrium is strictly segregated. We don't know is how segregated. It could be trivially segregated, everybody lives together, or perfectly segregated. What I do want to say is the following, and that is that the equilibrium in this model has a property, and that is if I ask the question, what distribution of families across neighborhoods would maximize the expected value of the gap between the child of the richest family and the child of the poorest family, it is the equilibrium allocation. In other words, the self-organization in the neighborhoods is actually, in terms of the support, riches versus poor, and expected value in the next generation, it is gap maximizing. The reason for that is intuitive, and that is the incentives in the model are for assortative matching. Exactly the same phenomena, by the way, occurs in the Becker marriage model, and that is of all the configurations of marriages, the one that maximizes the gap between the two families is exactly the same. The same phenomena occurs here. The second observation I want to make is that when one traces out the dynamics of each family, what happens in the model is, on average, an expected value, rich families have higher growth rates than poor families. And at the rate I'm going, there's going to be very few facts to justify the model. So let me really speed things up. Okay? And what I want to say is the following, and that is that what this model tells us is the following, and that is that if one looks at the model dynamics and looks at the richest family and the poorest family in the population, or looks at the top alpha percent and the bottom beta percent in the population, there is a positive probability that they will, if they are living in different neighborhoods, their descendants will never live in the same neighborhood. In other words, there will be permanent decoupling of the tails of the income distribution from everybody else. The reason for that are the incentives I described. With enough inequality, there's some possibility that the rich are going to isolate themselves, the poor isolate themselves, they grow faster on average, and the poor, and so permanently are decoupled from everybody else, the poor growing more slowly on average. Intuitively, if you ask the question, does a random walk with drift away from an absorbing barrier hit the absorbing barrier? The answer is probability is between 0 and 1. So this model never has a probability 1 poverty trap or affluence trap. What it means is ex post, there's a possibility one will have observed that phenomena. So that's result number 1. Result number 2 is that this model can generate a Gatsby curve. In other words, there exist non-trivial sets of income distributions that will generate a relationship between monotonic shifts of those income distributions and lower mobility. Now, I said that in a very weak way. I didn't say it's always true. One way to see why it can't be always true is the families are already segregated. Any changes in the income distribution won't increase the segregation. And so the phenomenon, it's actually a fairly subtle result to get. And one thing to keep in mind is the equilibrium of this model is this high-dimensional stochastic process in which you're tracing out all of the families. The Gatsby curve is this dimension reduction of the high-dimensional process into 2 numbers. And so some of there are cases, non-trivial cases as well, where the dimension reduction would not generate a Gatsby curve. All right, so that's what I want to say on this, on the theory. So in 5 minutes, how would I somehow persuade you that there's some empirical evidence for this? What I want to say is the following, and that is that there's evidence at many levels. One of them is that there's evidence actually directly of an intertemporal Gatsby curve. And so a paper by Aronson and Mazumdar, for example, which estimates changes in the IGE across time, finds some relationship between increases in the shares of the ratio of the tails of the wage distribution and the Gatsby curve. So those seem to have co-moved together. So have the share of the top 10% and the return to college. So all 3 of these are phenomena that would generate Gatsby curve, really kind of direct evidence. So that's the first thing I want to say. The second thing I want to say is that there is a location mobility nexus that has been identified. One example would be relationship of Carney and Levine, who showed that states that have greater variance of income have higher rates of high school dropout. So the thought experiment is more variance of income at a state level, more segregation. High school dropout rate hurts the lower tail. That slows down mobility. Of course, the second you're going to hear about at this conference, and that's the extremely important work of Raj Chetty and others, that has very specifically identified strong relationships between location and measures of intergenerational mobility. The third thing I want to say, and actually, like I say, is that income segregation is pervasive and growing in the United States. And so as an example, here's another map that illustrates how the spatial distribution of poverty in the United States. If one looks at income segregation in Chicago, one sees exactly the same phenomena. It's sometimes said that income is a fractal phenomena. Segregation is a fractal phenomenon in America. There's also some evidence that income segregation in America has been increasing while racial segregation has been decreasing. Now, to be clear, the level of racial segregation cannot be explained as an epiphenomenon of the level of income segregation, but nevertheless, those movements are suggestive of that. The final thing I want to say, and I should have said I had 4 things I wanted to say on this, is that there's spatial heterogeneity in factors relevant to human capital and skills formation. One example would be the per capita heterogeneity in public school expenditures. It's really quite dramatic in the United States. If one looks within a given state, this was not randomly chosen, Texas has extremely high levels of interdistrict inequality. And so the political economy, the logic, which is specific to the U.S. of local public finance, really does matter, despite programs that at the state and federal levels that try to reduce that. The final example I want to give in terms of social interaction effects mattering is exposure to violent crime. The question of the credible empirical inference on social identification is hardly resolved, and and so that would be a separate lecture on the state of the evidence. One thing I do want to say is that there's extremely robust evidence that exposure to violence damages education of children. And there is enormous segregation by exposure to violence, and that's both at the national level And as you may know, if you just take the city of Chicago, there was extraordinary concentration of violence there. All of those stylized facts collectively are suggestive of that phenomenon. Okay, so that's the first piece of evidence. The second piece of evidence is to construct IgE regressions. And so the idea is going to be to say that we can think about different ways to map the relationship between parental income to offspring income. And what we do in the paper is two things. We start with we do a non-parametric mapping and ask whether or not that would generate a Gatsby curve. And then we do parametric social models. And that's just a fancy way of saying this is what we consider our models, and I have a reason I'm skipping all of that, in which we say that the relationship between parental income and offspring income is also influenced by the average income of either census tracts or states. So I want to be clear, one was non-parametric, one's parametric. Now the reason I skipped all of that is what I want to show you is the following, and that is one can do this. You can actually take the estimated statistical model and then do the counterfactual. What if you start altering the variance of parental income? You use the model, in other words, it's given us the parameters, and one can actually construct an implied Gatsby curve from it. The observation I want to make is that if one takes the non-parametric model, one gets the opposite of a Gatsby curve. There's a negative relationship between inequality and persistence. So in other words, the idea that one can simply explain everything via nonlinearity doesn't work, at least from our estimates and the implied Gatsby curve. In contrast, if I use census tract income and variance, for example, as mattering, so this is just one representative figure, one gets a gently sloping Gatsby curve. And so the upshot is that when we go through these various statistical models and ask about the implied Gatsby curves, what we find at the end is the non-parametric, the strict nonlinearity approach doesn't seem that powerful. In contrast, at least and admittedly, it's not quite a level playing field because I used certain functional form assumptions. We do find a Gatsby curve is generated by the econometric, the statistical models we estimated. The final thing we do is we construct a calibrated model. We actually get data on school districts in the United States and write down every I dotted and T crossed model of family investment in which families are making decisions on investment and consumption and the like, and work through the model. This is where I'm really going to go crazy, and I'm going to skip everything because I just want to show you one picture at the end. So what we do is we fully calibrate the model, as I said, with all the I's and T's crossed, and then we ask the following question. Use the model to simulate data that's relationships between parental income and offspring income, and then ask what happens as one begins to increase the variance of parental income. So what one has is, in each case, one generates from the model, for the simulations, a set of data points. You just run a linear regression through. That is the IG estimate. And roughly speaking, what we get is a 15 to 20% increase in the parameter for the IgE if you increase the income, the standard deviation of income by 20%. And so that's what I meant when I said that the model is not providing some shocking result in terms of its capacity to explain a relationship between the two. If one takes as a baseline the idea that a point, to generate the numbers I had, it's a non-trivial part of the model, of the IgE, but it's by no means the whole thing. And so in other words, what the model is suggesting is the 20% standard deviation increase, which is empirically not a reasonable first pass on what's happened in terms of income, would raise the IgE by, as I said, something on the order of 15 to 20%. So that for us is the mechanism for the Gatsby curve. So what I want to say at the end then is that I've tried to make a case for that one can think about a generative mechanism for a Gatsby curve in which inequality begets segregation, begets changes in mobility, begets mobility. And that second, that there's some evidence, again, from three different dimensions suggestive of that approach. And the final thought I want to leave you with is that to the extent we think of segregation as the mechanism underlying persistence and socioeconomic status, that is suggested that one wants to think more broadly about the policies one implements. Now, I refer to those policies as associational redistribution. What that means is interventions that try to alter the equilibrium degree of segregation in an economy. To give a simple example to end the talk, There is very good evidence that so-called mixed income housing, in other words, the requirements that builders build housing that's affordable for people in different income levels, can be quite efficacious. And so I just leave it as a final thought that we often think about distribution just in terms of giving money from rich to the poor. There's something else that can be transferred, and that is the interactions with others. So let me stop there. Thank you.
Okay, so we actually got 3 to 5 minutes for questions. If you have any question, please raise your hand. We have student helpers here to pass you the microphone. Yes, this gentleman. Yes.
Thank you very much for the interesting talk, Mr. Durlauf. My question relates to, have you thought of what happens if you were to close the model? I mean, specifically, you started off with saying that the standard way that people think of causality is from persistence to the distribution, and you're introducing how the distribution would affect persistence. Now, if you were to close that, could you think of a process that leads to some steady, even with your growing incomes, to some steady state distribution of income? And then in your model, what would that steady state depend on, and how could one affect that in some sense?
No, I think it's a great point, and we could, in principle, do that. Our focus was just to get that coefficient, and so I'll be honest, we haven't calculated those, but I think that's a separate, very interesting exercise. It should be to simulate the model, either the statistical models or the calibrated model, and then look at the steady state income variance. That's a very nice point.
Great. Do we have any other question or? Yes. Can you pass that?
Have you thought about the possible channel of getting richer by marriage? Because there is some findings that riches are marrying rich, more educated are marrying more educated these days. Could this even further amplify the effect?
So we certainly do not do that in the model. I think it's an excellent point. There is a small literature that's argued that one piece of the mobility puzzle is increasing disorder of mating, really with respect to education in the American case. And I think I think the point's well taken. I mean, it's another example of memberships in the sense that I sort of threw in the family as the first one. Well, the degree of a sort of matching with respect to the spouses is clearly important. So I think your point's well taken.
So due to time constraint, and let's just call an end to this lecture, but feel free to communicate afterwards. And thank you so much, and thank you, Professor Durlauf.